Okay, so we're going to continue our study of parallel and perpendicular lines. Let's first define the perpendicular lines and their slopes. So there are two lines in the same plane that intersect to form right angles, and they're perpendicular lines. Those are perpendicular lines. Their non-vertical lines are perpendicular if and only if their slopes are negative, or some people say opposites, and the reciprocals. So looking at this, let's see if it fits our definition. Are these lines perpendicular? Looking at these two lines. Well, going back, it says that they have to have they're in the same plane. Well, they are in the same plane. But they have to intersect to form right angles. Or they have to be, their slopes have to be negative reciprocals. Well, these aren't right angles. I can tell by just looking. To be a right angle, it have to be at a 90-degree angle. So let me see if I can use this. This would be an example of a perpendicular line. These two lines more resemble parallel just looking at them, but perpendicular would be a negative reciprocal. So what would be the perpendicular line of this one? This is kind of like a y-axis, right? What would be the x-axis? Because it'd be negative, but it'd be reciprocal, and it would form these right angles, almost like a plus sign. In fact, all perpendicular lines kind of form a plus sign in a way. This is like a plus sign at an angle, right? It's like I turned it a little bit. Okay. So let's look at some examples of these perpendicular lines really quick. So I have three here. In order to find a perpendicular line, there's really only two steps you need to take. The first step is to form it into the slope-intercept form, y equals mx plus b. The second step is just to compare the m's. Look and see if the m's are negative reciprocals or not. So the first one's already done for us. We already have y equals mx plus b. The m is 4. That's kind of easy. All right, which is the same thing as 4 over 1, right? But let's look at this one. In order to find out if this line is parallel with this line, we have to put it into the y equals mx plus b format. So let's do that quickly. We'll do a negative x to one side, negative x to the other. So we'd have 4y equals a negative x plus 3. And then we divide both sides by 4. Now we'll move it to the side here. We'd have y equals a negative 1 over 4 x plus 3 over 4. Well, I can basically ignore the b, because all I need to look at is the slope. I'm comparing the m's. And so the slope on this one is a negative 1 over 4, and going way back up here, the slope over here was a 4. So they're opposites, because one's positive and the other is negative, and the reciprocals, because one is a 4 over 1 and the other is a 1 over 4. So yeah, if I were to graph those, they would actually be perpendicular. Let's check this one out and see what happens. So we need to, again, solve for y and compare the m's. Positive 2x to one side, positive 2x to other. Let's bring everything down that we didn't use. And then divide both sides by negative 8 to solve for y. And I'll write it to the side here. We'd have y equals a negative 1 over 4. Whoops, that's right. X plus 2, a negative 1 over 4. Going back all the way up to the first equation is the opposite reciprocal over 4 over 1. Therefore, it is perpendicular to the first equation. Again, I'm just looking at the m. But yet, it's parallel to the second equation because they have the same m. So one last thing as a quick summary. So parallel lines have the same slope. They would never touch. And so if the m was 3 on a parallel line, the other line would also have the m being 3. Perpendicular lines, they kind of make a plus sign, right? They form these right angles. And they're